In the previous video, we talked about the electric force and we also derived the Coulomb's law. So in this video, we're going to be solving problems related to the electric force. So this is our first problem. And this is that a +1 Coulomb charge and a -1 Coulomb charge are placed at a distance of 10 centimeter. How much force is acting between them? So Q1 here is equal to +1 Coulomb. Q2 is equals to -1 Coulomb, and the distance is 10 centimeter, which is 0.1 meter, and the constant K is, we know, 9 into 10 to the power 9. So what is the force? Pause the video and see if you can find it out. So electric force is equal to K times Q1 times Q2 divided by r squared. So just plug the values. 9 into 10 to the power 9 into +1 into -1 divided by 0.1 whole squared. And this is equivalent to, let's see, 9 into 10 to the power 9 by 0.1 squared. So negative 9 into 10 to the power 11 newtons of force is acting between these objects. And let's see our second problem. So here this says two charges of +5 Coulomb and +3 Coulomb are placed at a distance of 1 meter. Now a third charge plus Q, this is the third charge, is placed between them. Where will it not feel any force? So this means is that, okay, let's draw things here. So this is the +5 Coulomb charge particle, and this is the +3 Coulomb charged particle, and the distance between them is 1 meter. So the question says is that we have to place this charge anywhere between this 1 meter. Let's say here, anywhere. Actually, we gotta find that out, that where we should place the charge so that the, let's say this is Q1 and this is Q2. Q1 and Q2 does not feel any force. So if we make sure that these two do not feel any force, then the force between these two and the force between the Q2 and Q should be equal. So this is, let's say, F1 and this is F2. F1 should be equal to F2. So F1 will be equal to K times the, here the Q1 is +5, K times +5 times here is plus Q divided by R. So here R, the whole thing is 1 meter apart. So if this, let's say this is X meter, so this will be what? 1 minus X meter, right? So here the distance is X, and since F1 should be equal to F2, then it will be equal to K times, here the first charge is, let's say, yeah, so +3 coulombs, and this second charge is plus Q divided by the distance is 1 minus X, so 1 minus X whole squared. Oh, there is a squared. Yeah. Now all we have to do is just simplify. So these two values can be cut out, and these two as well. So +5 divided by X squared is equal to, okay, is equal to +3 over, okay, this formula 1 minus 2x plus x squared. Yeah. And let's cross multiply. So this will be 5 into 1 minus 2x plus x squared, and here will be 3x squared. So the whole thing will be 5 minus 10x plus 5x squared minus 3x squared should be equal to 0. This is our quadratic equation. So this will be 2x. This will be 2x squared. So let's rearrange things. So 2x squared minus 10x plus 5 will be equal to 0. So now what we should do is we should just plug the quadratic formula, since we cannot do the middle term here. You can see. So x will be equal to 10 plus minus root over, so root over b squared, so which will be 10 squared, which is 100, minus 4ac. A is this and c is this. So this will be 2 times 5 is 10 times 4 is 40. Yeah. Divided by a squared, which is 2 squared, which is 4. Yeah. So this will be equivalent to, well, x. If we take the positive value, then x will be equivalent to plus root 60 divided by 4.436 meter. And if we take the negative value, then x will be 10 minus root 60 divided by 4, which will be 0.56 meter. And since the whole thing is just 1 meter apart, and it says that this is 4.436 meter, this cannot be true because it's not in the range, and this says that is 0.56 meter apart. So this should be the right answer. This should be the right answer. So the distance here, this x will be equal to 0.56 meter, and this will be 1 minus 0.56 meter. Okay, let's just move to the next problem. So here it says there is a proton in the center of hydrogen atom and an electron outside it. So if the distance of the orbit of the electrons is 0.5 times 10 to the power negative 18, what is the attraction force between them? So in this problem, what we really need to do is, I think we can just plug the values. Let's see. So Q1 should be the charge of the proton. So the charge of a proton is plus 1.6 into 10 to the power negative 19 coulombs. And the Q2 will be the charge of the electron, which is minus 1.6 into 10 to the power negative 19 coulombs. And the constant is 9 into 10 to the power 9. And the distance is given here, 0.5 into 10 to the power negative 18 meters. So what is the force of attraction acting between the proton and the electron? So this will be equal to, okay, the force will be equal to K times Q1 Q2 divided by R squared, which is 9 into 10 to the power 9 into Q1 is plus 1.6 into 10 to the power negative 19, and Q2 is minus 1.6 into 10 to the power negative 19. And the radius, what's the radius? 0.5 into 10 to the power negative 18. 0.5 into 10 to the power negative 18 whole squared. So this will be equivalent to, okay, let's calculate 9 into 10 to the power 9, right? Into 1.6 into 10 to the power negative 19 into 1.6 into 10 to the power negative 19 divided by 0.5 into 10 to the power negative 18 whole squared. So this will be negative 9.22 into 10 to the power negative 12 newtons. So this is the attraction force acting between them, the electron and the proton. So yeah, maybe this is our final problem. So let's see what it says. How much charge should be stored in the earth and the moon so the gravitational force becomes zero and the moon comes out of its orbit? Okay, this is a question of some higher thoughts. So let's see. The gravitational constant is 6.67 into 10 to the power negative 11. And the mass of the moon is 7.35 into 10 to the power 22 kilograms, and the unit of this is Newton kilograms inverse 2 meter inverse 2. And the mass of the earth, well, these things should be given in the question. I didn't give it, but yeah, 5.97 into 10 to the power 24 kilograms. And the radius, or the distance between the moon and the earth, is 3.84 into 10 to the power 6 kilometers. Since everything is in kilos, so we don't need to convert anything to meters, right? So let's see. The gravitational force is equal to the constant times the 2 mass divided by the distance squared. And in this case, it should be equal to 6.67 into 10 to the power negative 11 times 7.35 into 10 to the power 22 times 5.97 into 10 to the power 24 divided by the distance, which is 3.84 into 10 to the power 6 whole squared. And this should be equal to, okay, let's see, let's calculate. 7.35 into 10 to the power 22 yeah, this will be equal to 1.98 into 10 to the power 20 newtons. So this is the force acting between the earth and the moon. So if we want to make the moon come out of its orbit, we'll have to exert this same force between them so that the moon goes out of its orbit. So we need to create, so what we need to do is, so let's say this is the earth and this is our moon. So if we add q plus q amount of charge in earth and plus q amount of charge in moon, so that the repulsion force, the repulsion electric force, is equal to the, well, to the gravitational force acting between them. Gravitational force acting between them. This should be the equation. So if we need to do that, Okay, so since both of the charges are same, should be same, then we can say that q1 is equal to q2, and we can denote both of them as q. You should add either up both positive charge or both negative charge, because they will have to repel, right? Yeah. So here the electric force will be equal to K times the both charges are same, so Q times Q divided by the R squared, and the radius is same between them, 3.84 into 10 to the power 6, 10 to the power 8, 3.84, 3.84 into 10 to the power 8 whole squared. Okay, maybe I've done a mistake over here, so this will be 8. Sorry about that. Whole squared, and this will be equal to K times Q squared divided by 3.84 times 10 to the power 8 whole squared. So see, what I told here is the gravitational force will be equal to the repulsion force created by the two charges, and that's when the moon will come out of its orbit. So this should be our equation, and we can just write it like this: 1.98 into 10 to the power 20, 1.98 into 10 to the power 20 should be equal to this, 9 into 10 to the power 9, which is the value of K, times Q squared divided by 3.84 into 10 to the power 8 whole square. And if we calculate this, let's see. Yeah, so this will be here. Yeah, so the Q squared will be equal to 3.24 into 10 to the power 27 coulomb squared. So the Q will be the root of this term, which will be 5.69 into 10 to the power 13 coulombs. So this amount of charge should be placed both in the Earth and the Moon, and then the Moon will come out of its orbit. So these were some problems related to the electric force. Hope this helped. See you in the next video.